Algebra 1 students, you've come to the right place. Section 8.4, multiplying special cases. And if you weren't pumped up enough, just listen to this. That's right. We are ready to multiply. All right, let's do this, folks. The big idea today, there are special rules you can use to find the square of a binomial and the product of a sum and difference of a binomial. First of all, we're going to look at squaring binomials. A plus b, quantity squared, we could think of it as a plus b times a plus b, which would then give us a squared plus, using the outer terms, the FOIL method, a times b plus inner, a times b, plus last, b squared. It simplifies to this, a squared plus 2ab plus b squared. Now I should probably also include here an alternate version of this, a minus b quantity squared would be always in the form of a squared minus 2ab plus b squared. If you memorize those two patterns, and really it's just one with a changed sign, it'll save you some time as we square binomials that are in that form. All right, the other situation we look at is a product of a sum and a difference. You can see the case right here, the general idea, a plus b times a minus b. Up here I've used the FOIL method, but down here you can see the middle terms cancel. We're just left with a squared minus b squared. All right, so let's do this then. First example, x minus 3 quantity squared. Now we could write this out and use the FOIL method, the distributive method, or we could even use that chart that some of you liked, the table. However, what I'm going to do is follow the pattern. I know that this is in the form of a minus b quantity squared. So think of your x term as being a, your 3 as being b. So when we do a minus b quantity squared, it's a squared minus 2ab plus b squared. And I'm just going to go ahead and jump straight to the answer. A squared is, in this case, x squared. 2 times x times 3 would be 6x. And then b squared, b term is 3, that's plus 9. That easy. All right, let's try another one. 3x plus 4 quantity squared. Now this is in the form of a plus b quantity squared. Think of it that way. And so we know the result then is a squared. Well, that's 3x quantity squared plus 2 times a times b plus b squared. Now I'll go ahead and simplify this. So we have 9x squared plus 24x and plus 16. I'm going to pause the video here. Do number 3. Compare your answer to mine. All right, welcome back. You can see my solution here, a squared minus 14a plus 49. Take a look at my work, compare it to yours. See if you've got this thing figured out. All right, let's take a look at a little application of this type of thinking. Simplify by using mental math. Now here's what I'm going to look at. For 17, I know that number is close to 20. So I'm going to do it this way. I'm going to write 17 as 20 minus 3 quantity squared. Now, if I follow the pattern we've been looking at, a squared minus b squared, that would mean our result could come by doing 20 squared minus 2 times 20 times 3, and then plus the last term squared. So 400 minus 2 times 20 is 40 times 3 is 120 plus 9. 400 minus 120 is 280 plus 9 is 289. Now I know some of you are going to say, well, Mr. Hale, I could have just grabbed my calculator and it would have given me a correct answer in a much more timely fashion. I totally understand that, but we're just looking at applications, and I think having some mental math skills is going to pay off for you long term. So number 5, we're going to do a similar idea, but this time it's a little more than 60. So I'm going to do 60 plus 1 quantity squared. I'm looking for a nice round multiple of 10, or if it were a larger number, maybe even a multiple of 100 at some point. But I'm looking for numbers close to multiples of 10. So this then would be 60 squared plus 2 times 60 times 1 plus 1 squared. Now 60 squared, you can figure that out because you know 6 times 6 is 36, and you've got 1 0 here. When you square it, there are going to be 2 zeros. Then plus 120 plus 1, which would be 3,721. Now you can test that on your calculator if you'd like. I hope it's right. I think it's right. And I'm going to pause the video and do number 6, and you do the same. All right, you can see my work on number 6. Hopefully yours matches. Let's continue onward. Now we're looking at sums and differences. So on number 7, we see x plus 2 times x minus 2. Now this is the second variety that we looked at earlier, a plus b times a minus b. Now this is actually one of my favorite types of things to do with factoring because, or I should say multiplication, it's the opposite of factoring. But because we lose the middle term, the plus 2x and the minus 2x cancel each other out. So all we're left with is first term squared. In this case, it's in all cases, it's minus the second term squared. So real simply, the solution is x squared minus 4. Let's take a look at the next one. Again, we see that pattern, a minus b times a plus b, or a plus times a minus, it doesn't matter, it's the same thing. And all we have to do is take the first term and square it, and we subtract the second term squared. So this is 4x squared minus 9y squared. Again, pause your video, work through number 9. All right, welcome back. You can see my work on number 9. I'm hoping that yours matches. Just follow the pattern. It's not that the old FOIL method or distributive or table method don't work. It's just that this saves you some time. All right, let's, as we did on the last pattern, let's go ahead and take a look at how this could be used for mental math. When we multiply numbers that are close to another nice round number like a multiple of 10 or a multiple of 100, we could use this same idea. So for instance, 43 and 37 are both 3 spaces away from the number 40. So I could rewrite this as 40 plus 3 times 40 minus 3, and all of a sudden we have that a plus b times a minus b pattern. So this then would have to be 40 squared minus 3 squared. 40 squared is 16 with 2 zeros after it. 3 squared is 9, and we get 1,591. Who knew you could do that without a calculator and without having to write it all out? All right, let's try number 11. 84 times 96. Now hopefully you're looking at this and saying, 90, close to both numbers. So we'd have 90 minus 6 times 90 plus 6. So again, we can use that product of a sum and a difference. So 90 squared minus 6 squared. 9 times 9 is 81, but when you do 90 times 90, you're going to have to put those 2 zeros there. We'll subtract 36, and this would be 8,064. Beautiful. No calculator needed. Again, for one last time, pause the video, work through number 12, and then hit play to see how you did. Here is my solution. I hope yours matches, and I think there's no better way to end this than with some outro music. So here we go. I hope this lesson is great for you. You guys have a lovely day. Come to class ready to work. And we're going to learn this stuff the right way. We'll see you later.